Hi, everyone. We're looking at the 2012 released assessment questions. So you should be able to go on before actually watching the video and attempt the questions on your own first would be better than just watching the video. I think it's best if you actually practice the questions and then actually see this. Maybe I do them a little bit different than how you would do your solution. So we'll flip in. Now this is a lot longer than the actual booklet you will have. When we actually have the assessment, it'll be 7 multiple choice, 4 open response. So that's like where it's not just circle, fill in the bubble. You have to show your work, and then another 7 multiple choice. That'll be day 1. Day 2 is the exact same thing again. So 7 multiple choice, 4 open response, and then another 7 multiple choice. Okay, so let's start this. I don't know if I can do the whole thing on this video. I did one yesterday, and the video quality or the audio was not great. It was very chopped up. So I'm using a microphone today, so hopefully it's a little bit better. So in the first one, what is the value of x squared when x equals 4 over 5? So I'm going to write 4 over 5 squared. And of course, they're going to have most of the answers that we might make mistakes with. So I could see somebody going 4 times 2, but this is 4 squared, which is 4 times 4, 16. And 5 times 5, 25. So there's our 16 over 25. Okay. Now you'd go on the bubble sheet and actually fill in the letter D. Okay. Number 2. We have a volume of rectangular prism is represented by 12x cubed. The height is represented by 3x. Which of the following represents the area of the base? Now they told us the volume is area of base times height. So let's just fill in what we know. The volume we're told is 12x cubed. The area of the base is actually what we're looking for. So I can leave that as area of base. And the height was given by 3x. So the question comes down to something times 3x gives me 12x cubed. So something times 3x gives me 12x cubed. So we should be able to see that the area of the base equals, first of all, 3 times we need a 4. So we right away realize that the 9s aren't working for us. So we know it's going to be a 4. And now the question is it x or x squared? So x times x would give me x squared. X times x squared would give me my x cubed. And actually they had an x cubed in here. X cubed times x is x to the 4. So we'd want the 4x squared. So you could always check it out after. So just up here, I'm going to go 4x squared in brackets times 3x. Now, a couple of you had difficulties on the quiz on this. When we multiplied 4 times 3, no problem. But when you didn't see an exponent on this x, you assumed it to be 0. So when you add those, you actually came up with x squared, but it actually means there's an exponent of 1 on this, so we get x cubed. Okay, so hopefully that's okay. Moving up to the next question, number 3. This one I think's a little bit on the tricky side. She scores 35% of the total team points, and she scored 38 points. So I might set this up as a proportion. Now, we didn't do a lot with proportions. Now, I noticed some of you, when you came to solving questions, quite often you were doing a cross multiply, which was nice to see. So I might go with points and percent. So we know she scored 28 points, and that represented 35% of the points. And we're trying to find out what 100% of the points would be. And we'll put x here. Now notice this is pretty darn close to 33%, which is like a third. Okay, so if it was 33, we could basically just multiply this by 3. Okay, so I'm looking at this, 30 times 3 would be up around 90, a little bit less than 90. So I'm thinking probably D is the answer, but let's go ahead and we'll calculate this. So I'm going to cross multiply here. So 35 times x is 35x. And 28 times 100 is 2800. So to solve for x, we need to divide both sides by 35. Which looks like 80, but we'll just double check here. I'll pull up a calculator. So sure enough is the 80. Okay, so we'll put in x equals 80. Normally, if this was an open response, we'd be looking for a therefore statement, but again, this is going to be fill in the dot, circle it. Make sure you circle it, because if you ever mess up on the bubble sheet and you kind of lose track, you messed up, you might just want to double check after. Okay, 4. This one should be pretty straightforward, just simply multiplying into the brackets. And again, I know a couple people had a little bit of difficulty with this. So again, multiplying in. So I'm going to get 12x minus 15 minus 63x plus 14. So let's look at how many x's we have, collecting like terms. I have 12x and minus 63. So that brings me down to a minus or negative 51. I guess that's all the options are there. And the last one, negative 15 plus 14. So I always think of negative 15 plus 14. You can punch it in your calculator, but negative 15 means I lost 15 or $15 maybe. And then I win 14. So I lost 15, I won 14. I'm still going to be down, and I'm going to be down only 1. Okay, so there's our answer here. Next one, a little bit of a tricky one. There's kind of like 2 variables in this one. There's he earns $10.50 per hour, and he also makes 40 cents per sandwich. Now, the question says, how many sandwiches does he need to sell during a 6-hour shift to earn $125? So his earnings, it's $10.50 an hour. So normally I'd put an N in here, but we already know it's 6 hours. So I'm going to put the 6 in here. Plus it's 40 cents per sandwich. So we'll put N for number of sandwiches. Okay? And now we know the earnings has to be 125, so we'll put 125 in. Now you could always do trial and error, I guess, too. I prefer not to even look at the answers if possible. I like to try to solve it and then see if the answer is there. But in some cases, by all means, it's probably best to actually look at the answer and check it, even though that's not, the way we normally want to solve things. So 1050 times 6 should be 63. Let's just use our calculator, double check. So 63 plus 0.4n or 40, oops. I'm not using my smartboard today, I'm using a tablet, so it's a little trickier for me to write, but hopefully the audio is a little bit better this way. So 125 minus 63 would be 62. Then the last thing we need to do, again, is divide by 0.40. N equals 62 divided by 0.4. And I get an answer of 155, hoping that 155 is one of the choices. So guys, if it wasn't, I would probably redo the whole question. So if you get an answer like, negative something, obviously you did something wrong. So maybe try a different approach. Okay, turning the page. So here's an open response dealing with percents. Remember we had one with the golf clubs before. So tennis racket this time. Mind you, the golf club one was a little trickier because we're trying to figure out how much would it have to be on sale for if we only had I think it was $450 to spend. So this one, a tennis racket, original price is $75. They're on sale for 25% off, and then there's an additional 10% off the sale price. The mistake some people do is they want to just add those together. Now it would be in the ballpark if you added 25 and 10. And if you're doing it that way, you might as well, take off or add on the 13%. Okay, but so really what you got to do is take 25% off, find that price, take an additional 10% off that new sale price, and then add your sales tax on, okay? So we're going to go with initial discount. So it's going to be 25% of our $75, which is 0.25, and of always means times 75. So 0.25 times 75 in our calculator, I think that's about 1875 maybe, because it's a quarter, right? So I always, anytime I multiply by a quarter or divide by 4, I just divide by 2, divide by 2. So 3750, then half of 3750, but just to be safe. Oops, I punched in 3750. I kind of got ahead of myself there. Okay, so let's check that again. So it's 75. Now, because it was 3750, I could really just times this by 2. Trust me, it'll be the same. So it's 1875. So new sale price equals 75 minus our 1875. I'm just going to use a calculator here on my desk here. I think it'll go a little quicker. 75 minus 1875 is 5625. Now we have our second discount. Now to get this, I realize I saw some of you were a little quicker with this. What you could do is, if it's 25% discount, that means you're actually paying 75% of the original price. Nothing to do with this $75, don't get mixed up with that. But 25% discount is the same as 75% of the original price. So we could have went 75 times 0.75 and we would have got this answer right away, okay? So same thing, if it's a 10% discount, we could just take this and times it by 0.9, and that would give me the, final sale price before tax. But we'll go second discount here, so we'll be consistent with the way we did it the first time. So second discount is going to be 10% of 5625. So 10% divided, because remember percent is out of 100, so divide by 100, I get 0.10 times 5625, and I get $5.63, rounded to the nearest cent. So final sale price. Like a lot of people will see 50% off and then take an additional 50% off the rack. A lot of people would think that's almost free because that's 100%, but you actually have to take 50% and then 50% of that price. So take an article of clothing worth 100, 50% off brings you down to $50. The other 50% brings it down to 25, so it's really 75% off. So final sale is, or I should have said maybe final sale price is going to be $56.25 where we left off, minus the $5.63. That gives me $50.62. Okay. Now to figure out the tax, we can just times by 0.13 if you want to actually figure out what the actual tax is. The other option would be to times by 1.13. Okay, so final price. This is including tax, and we should really put a little therefore at the end. So 50.62 times 1.13. Now, if you don't like the 1.13, stick with the 0.13. Keep in mind that's the tax that we'll have to add on to our 50.62 after. So I'm just going to times that by 1.13, and I get 57.20. Therefore, the final price after tax is $57.20. Okay, so hopefully that makes sense to you. Okay, and it seems reasonable, eh? Our tennis racket started at 75, couple discounts, add tax on. The discounts were bigger than the tax, so we should be still less than the 75. Consider the graph below. Which relationship is most likely to be represented by this graph? So height and weight. So So just think about it. If I put height here and weight here, so as the weight decreases, would the height decrease as well? Sorry, this would be weight increasing? No. If somebody's height is increasing, weight is also increasing. That would be more of a, going up to the right. Okay, so that one I would scratch out here. So the first one is not right. What about pay and number of hours worked? Again, that doesn't make sense because as the number of hours increase, as we go out this direction, your pay should also increase. So that would be work 0 hours, you get paid 0, and then it should go more up like this. Okay. Gas remaining in the car versus distance traveled. So let's label this one here. So gas remaining and distance traveled. So the further the distance you traveled out here, does it make sense that you'd have less gas remaining? Yes, and that's initially what should happen. You should have like a full tank. So yes, that one makes sense. Let's just double check the last one, volume of water in a bucket versus its mass. Yeah, so as the volume increases, so does the mass. So anytime they both are increasing, that would mean it's going up to the right. So pay, as the pay increases, number of hours worked increases. As height increases, weight increases. Okay, so those would all be up to the right, where this one here is as distance travel increases, the gas remaining actually decreases. Okay. The figures below are made with sticks of equal length, so kind of like toothpicks. The pattern continues in the same way. Which table shows the relationship between the number of sticks, S, and the number of figures, and the figure number, N? So the first one has, I almost want to say 1 block, but it's actually 4 sticks. Okay, so the first one looks okay, 1, 4. I don't know if they probably all have 1, 4. No. So the first one, you might jump on that one, but keep in mind, I don't know if 220 necessarily works. So let's actually count the number of sticks here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I counted correctly, it should have been 15 for number 2. Now, you might notice, what are they really doing to, so if you're making this, what are they really doing? They're just adding on 3 sticks here, 3 sticks here, 3 sticks, 3 sticks, and 3 sticks. So that's 3, 6, 9, 12 more. So if we count the original 15 plus 12 more, would be 27. Okay, so we see the second one, 220 and 336 is not working. So if we had figure 4, you're welcome to draw it, but we would see that it goes up again by, should go up by another 12 again. So that would bring me up to 39. So we could actually make our own table. With N and S. So instead of X, that was, oops, my writing tool here again, N and S. So we see 1, 2, 3, 4. Okay, so initially, guys, the first one was 4. Then remember, went up by 12. I could look up again. I think it was that right? 60. Oh, did I count wrong? 1, 2, 3, 4, 8. Yeah, this second one should have been 16, which means this one was 28, which means this one was 40. Good thing we checked that, okay? So 16, 28, 40. So let's see if any of these are kind of matching up. So the first one doesn't. 440 works. 312 doesn't for this one. Notice 312, we had 328. And what about the last one? How's it? 517. 517 definitely isn't going to work because our next one would have been 52. So it's looking like B, but let's just double check. 552 also is there. 6, yeah, up by 12 again would be 64. Okay, so there's our answer. A little trickier. Why we didn't really see any of those in the course with the sticks so much. And maybe once or twice with some sort of patterning. Okay, next one. Which of the following represents a non-linear relation? So remember linear? Well, this one's definitely linear. It's a straight line. Linear, you actually see the word line right in it. So, but mind you, it's non-linear. So line. So this one's linear. Now, if you're given you might think you got to graph this out. But remember our first differences? Most people did really well with this, but when we find first differences, it's the differences in the y. I think some people are going 1 minus 1, 4 minus 2. No, it's 4 minus 1, 9 minus 4, 16 minus 9. So these are not the same. Okay, when these are the same, that actually means it is linear. So this is actually non-linear. So we already found our answer. Now you might want to look at the other two just to be sure. Well, y equals 2x plus 3 is in the form y equals mx plus b. So that's definitely linear. And the last one, let's see if this how the first differences work this time. So 5 minus 8, negative 3, 2 minus 5, negative 3, negative 1 minus 2, negative 3. Okay, so the equation of this one actually would be y equals negative 3x plus b, because the first differences represents our slope, or m value, provided these are going up by 1 or down by 1. Actually, we kind of slipped up there because it's going down by 1. We should have been subtracting the other way. Okay, so normally you'd never see a table written 4, 3, 2, 1. Normally you always see 1, 2, 3, 4. So a little error, I guess, on their part, but really our slope would have been positive 3. But for determining whether it's linear or non-linear, it doesn't matter if you go 8 minus 5 or 5 minus 8. That makes no difference. Okay. A line of best fits drawn. The slope is negative 2. And yes, we could actually see the slope is negative 2. Pick any point along here, and it looks like we're going down 2 over 1, down 2 over 1, because you could say that's equal to negative 2 over 1. So the question is, which equation represents the line? So remember y equals mx plus b, m representing the slope. So this first one's definitely not right. That has a slope of 6. Next one, slope of 3. So it's one of these two. So remember the b represents the y-intercept. What does the y-intercept appear to be in this case? Y-intercept appears to be 6. So the answer, nice easy one, that's going to be y equals negative 2x plus 6. Okay. A couple more, then I'm going to have to stop. Bruno leaves home and goes for a run along a straight path. He runs. So the straight path tells me he's probably running at a constant speed. If he's running uphill, he's probably going to be slowing down. So he runs to the park, stops for a rest, and returns home. So A at first kind of looks okay. I see that he's running along a straight path, constant speed. Then he stops, and then he continues to run, maybe a little bit quicker this time, mind you, because it's a little steeper. But it's distance from home. So where does he leaves his home. So he starts at home, so it should have started down here. And if he's coming back to his house, he's going to have to finish here. So let's look at the next one. B looks pretty good again. Starts from his house, constant speed up here. Stops for a rest, looks like maybe 3 minutes, even though they don't have scale on here. And then he continues to run again. Okay, but where does he finish up? He finishes down maybe at his friend's house or something. Okay, C part. This would be if he actually started at his friend's house, ran home, maybe ran in, got a drink of water, and then he left and he ran back to his friend's house. So that one doesn't work for us either. Hopefully D works. Yes, D, he runs at a constant speed. This would tell me how far away he got. So maybe this is 50 meters. Maybe this is, maybe it's minutes, 2, 3, 4, 5 minutes. And this is 7 minutes, so he stopped for 2 minutes and then he returned home. Okay, so D is the right answer. Oh, this is an interesting one. It's a cell phone question, and it's talking about the number of remaining, value of your card. So total number of minutes used was 10, and they have $22 remaining. After 20 minutes, they're down to $19 remaining. Okay, so what I chose to do, I just stuck in a quick little graph here. I did this yesterday again, but the audio was really, really poor. So I just plotted these really quickly yesterday. I just went 10, 22 was roughly here, and 2019 I put roughly here. Drew in my line, and the other thing you could do is work backwards to find what the y-intercept would be. So 20 to 10, we're going up 3. So go up another 3. We see the y-intercept should be 25. So it's going to be C or D. Also from the graph, we see that it's not going to be 22, because if it was 22, our line would have to go straight over from here. You know what I mean? It's going to continue up in this trend here. Okay. Okay. The other thing we got to figure out is what the slope is. The problem is, you guys would look, a lot of people would look at this and see the slope. Hey, we're going down by 3, down by 3. Think the slope is 3, but this is not going up by 1s over on this side. This is going up by 10s. So you got to actually calculate the slope. So I don't know if you want to find the equation, or maybe we'll just go ahead and find the slope here. So the run, again, a lot of people call this 2, but look at the scale. So the run here is 10, and the rise here is actually -3. So going from this dot to this dot, we had to go down 3, and then over 10. So my slope is equal to, or my m is equal to, -3 over 10. Now again, you could have did the same thing, just choosing, 22 minus 19 over 10 minus 20. Okay, so remember, we also have slope is equal to y2 minus y1 over x2 minus x1. So again, if you want to do it from the table, we didn't make a graph, say, 19 minus 22, 20 minus 10. So I get -3 over 10. So I get -0.3. or -0.30 if you want to put that in. Okay, so we know the y-intercept is 25, either using the table or using the graph, and we know the slope is going to be -0.30 using the table or again from the graph. So here's my answer down here. Okay, so a little trickier. Okay, so another one coming up with the equation. I'm going to have to do this one quick because the bell is going to go here any minute. Okay, so relationship between the total cost to use a gym for a month, and C is the number of visits, and in the partial variation. So it's saying a relationship between the total cost. So partial variation, remember direct variation starts off at 0, 0. But a lot of gym memberships, they charge you an initial charge, maybe $20 a month, and then maybe $2 per visit, okay, or maybe $5 per visit. So the total cost for 10 visits is $50. So we'll put some scale on here. So we'll have our visits down here. Oops. And it's $50. So 10, 20, 30, 40, 50. I got to clear out of my room. I have somebody coming in this room this period. So 10 visits was $50. So we can draw any line now. So I don't know if you want to pretend it was like started at $30 and it goes through that point. Okay, or we could have chosen 40. Okay, just the only one we couldn't choose was 0 because they said it was partial variation. Determine the equation of our graph. So this is going to be different depending on what you chose here. So we need to figure out what the slope would be.
Austin Bickle and Donovan Smith report to room 104. Austin Bickle and Donovan Smith.
Okay,
room
so we
104.
see this is up 15. And my run would be 10. It's 15 and 10, so my rise is over run, 15 over 10, which is $1.50. So it's going to be 1.5 N for the number plus my y-intercept of 30. Okay, I'm going to leave out the explain because I have people at the door here. Okay, hopefully that helps. I'll continue the rest of this another day. Okay, bye for now.